Good morning, mathematicians. How we all doing today? What will we yap about today? Is the other question. Good morning, mathematicians. I have no idea. Maybe more op-rad stuff? I don't know. Like, whatever you want to yap about. What do we got here? Some infinity category Langland stuff. Crazy. Okay. What are we doing? Yeah, maybe more stuff about operads, I guess. Oh, 7:30. It's early. This is an early office hour. Probably people were used to me starting later. Also watching Naruto. Well, yeah. Hello, Kostaka Corey. It reminds me of, there's this video, what is it? What is it? This, like, meme. Yeah, right here. Oh, it's this. No, there was one, but then there was also, it was this, but then there was also, like, battle strategies happening on screen at the same time. That's like the Giga Chad learner. I now start when you wake up. Well, we're perfectly in sync. Early worm gets the worm. Yeah. Yeah. But the Ouroboros has always gotten everything, always, all the time, since forever, and will always into the future. So consider that as well. Yeah. Yeah. What to say? I could say a little stuff about, since Leo, since you're here, you're asking about supercuspidal representations. You recently learned the characters for Sun Tzu. And you also learned how to type characters on the keyboard. Interesting. One thing I will say about the supercuspidal representations is something about how they show up in the Langlands correspondence. I should just make some videos on this. But you listen to Kant to go to sleep. It's as abstract as most math books. Is Kant that hard to read? I've never seriously read any philosophy. That's not true. I've read some Plato, some English translations of Plato. There's a special character for philosophers. That's interesting. I thought Hegel was the real abstract one. There is also, actually, do I want to spend time talking about this? Maybe I do. So we have the V group. Is this, like, dense subgroup of the absolute Galois group of QP. Oh, you know what I want to do? I want to look at, I know what I want to look at after this. In Mencius? What's Mencius? I don't even know that. Sun Tzu. I think that's a different Sun Tzu though, right? There's no way that's not the same guy, right? I thought it was a different Sun Tzu. I did know that because I remember talking about it with my master's supervisor, and we were like, um, there's no you're pretty sure not. Yeah, yeah, okay, yes, yeah. Definitely a different guy. That's what I thought. Yeah, but yeah, we were talking about the fact that it's like, well, we don't say this. There's no like the United States theorem or like the Canadian theorem. Like we always attribute this to some person, so we should attribute it to someone. Troop counting theorem. Interesting. Huh. That's interesting. That's really interesting. What they needed to. Yeah, I guess I could imagine you want to divide. You're trying to solve a linear system of equations, mod n, and you want to solve it because you want to know that you can group certain, like a certain unit of soldiers into certain subunits of certain sizes. Yeah. There are two Sun Tzus. That makes no sense. Yeah, there's only one Leo Lectures, which is why it's confusing for you that there's two Sun Tzus, I guess. If you get that character in your name, there won't be two of you. Well, who knows? What if I change my name and become a famous philosopher? You know, I've been trying to keep the caffeine content lower, but some days it's hard. Some days it's fine, some days it's hard. You call synthetic division Ruffini's method. Really? Does that come from Ruffini? Which grad course do I like the most? The least. Oh, interesting. Interesting. That's an interesting question. I don't know. I don't think any of the reasons, I just like math in general. So I don't think any of the reasons I would rank some grad course over or under another grad course really has anything to do with the mathematical content. I think the only thing that would have determined a preference for one course over the other was just more the like interpersonal experience is in a certain course. You know what I mean? I guess there's some subjects I like more. But yeah, which grad course do I like the most least? Well, what have I even taken for grad courses? What did I take? I took I'm trying to think now. I took Analysis 3. I took Algebra 3. These are my PhD courses. I took Representation Theory. I took Number Theory. And I took Measure Theory. I don't know. They were all fine. And what did I take in my master's? I took. Okay. I can. Yeah. Okay. I took differential equations 2. Or was it 3? I don't remember. I took functional analysis. I took also algebraic number theory. There should be two more courses. What did I even take? Algebraic topology, I think. And uh, what else? I think I had one more course. Can I find my master's thesis or my master's um No, I tried looking for my transcript before and I don't know where I put it. It's somewhere. Um I don't think these are my master's transcripts. Um Damn. So I was not forced to take applied math courses. No. That wouldn't make any sense. Um Let's see. Can I see from here? These are some of the courses I've taken. Oh, complex analysis 2. That's the one I was missing. Okay, so these are all the courses I've taken. Okay. Differential equations 2. This was awful, but just because I thought the instructor was not very good. Yeah, I don't think I learned anything in that course. I mean, he graded very easily, right? Because I had no idea what was going on. So I just wrote random slop in my assignments, and I got a decent grade. He just was like very bad at explaining. It was very loose, very messy. Yeah, did not enjoy, but it wasn't necessarily. I mean, differential equations really isn't up my alley, but differential equations really wasn't up my alley. But still, I probably could have enjoyed. I think I could have enjoyed that course had someone else taught it. Likewise, speaking of, so this is not just, I promise this is not me hating on analysis. Analysis 3, I never went to class because he didn't actually teach. He just read, like, directly from Rudin verbatim. And so why would I do that? From various different Rudins, I should say, the 3 Rudins. But why would I go to class? It was, I was listening to a guy read directly out of a textbook about things I had already learned. So I know there's a lot of questions in chat. I'm behind on here, but yeah. Representation theory was fine. I was just a little checked out. It was like a spring course. It was the last course I had to take. And you would have thought I would have done the best on that course out of everything being a representation theorist. But at that point I was just like, I'm doing other things now. I'm tired of taking courses, and so I didn't do great in that course. I didn't do bad, but I didn't do great, which is a little embarrassing because then that prof probably thinks like, why is this guy doing representation theory? He didn't do very good in my course. Yeah. What else am I going to say? So green, I mean, of course, I really enjoyed algebraic number theory. Except in this algebraic number theory, I wish I had worked harder to understand. I feel like I just got by. I got a fine mark, but I feel like I just got by. Even in this one too, but it's hard because there's so many distractions in life. Like I wish I could have just spent the whole semester strictly thinking about algebraic number theory. Functional analysis was difficult. This was a hard course. I think just the professor asked tough questions and graded somewhat tough. But I don't think it was necessarily unfair, and I always appreciate the people who grade who grade their courses strictly, because then that makes me grow the most. And so this is why I grade strictly as well. Um, okay, you know what? Instead of me, you know what? This actually gives me an idea. Let me go back to uh, let me add this to FAQ. Uh, so I'm gonna maybe I'll what I'm gonna do is I'm gonna make some videos where I review all of the courses I ever took. Um, I think that's what I'll do. Uh, so which one did you fall in love with the professor? Uh, well, not the ones where the professor did a bad job. Every other course I did. Every other course I did. If no math were to leave any country as of now, which country do you think would have the most advanced math? That's so hard to say. That doesn't. Yeah, it's impossible to say because, like, all of the math is a multi-country collaboration. I mean, I don't know. I guess. Yeah. I, I guess the States and UK have a high concentration of very prestigious universities, so there's a lot of very good people there, but I mean, there's a lot of very good people in a lot of other countries as well. I guess maybe though there's just more in those. I guess yeah, I don't know. I don't know. I guess China has a lot too. I don't know. What's analysis 3? Functional analysis and algebra 3 would be commutative algebra or homological. Yeah, so in my algebra 3 course, um in my algebra 3 course, this was like rings, modules, homological algebra, and the classification of modules over a PID. How much spare time do I have for myself while doing a PhD? As much or as little as you want. As you might have seen when I popped open that little window. My frequently asked questions is one about that. So eventually I'm going to make a video about all my frequently asked questions. But yeah, as much or as little as you want. But of course, if you take too much free time for yourself, it'll take you a long time to finish, and your supervisor won't be happy with you. And then that's not good. So, yeah. Okay, we're not that far behind. Oh, hi, Mom. Sorry, I missed your message. Love you. I'm just behind reading all the messages in chat. This actually happened post World War II, and Soviet mathematicians weren't really allowed to communicate with the rest of the world. Yeah. Are we doing analysis? Not at the moment. We're just yapping right now. It's the same sun too? Huh? What? No way. You're saying it's the same Sun Tzu? No way. That's a very strong master's program? What? Just 5 courses? I don't think so. It was the most beautiful slop ever seen. Got it. Put lots of differential equations in Math Jeopardy. Oh, God. Your task is to debug GA code because you don't know what you did wrong. You know, life do be like that. Shudo, I think they're talking about geometric algebra. I don't know what is G code. What's G code? They just mean they've coded up some geometric algebra stuff. Yeah, I would say Alufi's Chapter 0 covers algebra covered in PhD programs. I think if you understand, if you know, of course I know Alufi. This is the only algebra book in the world, as far as I'm concerned. Kidding, but not totally kidding. Yeah, if you know a Luffy inside and out, then I mean you're golden. Um, there's maybe some things that are possibly missing. Um, but yeah, I think I think a Luffy covers a lot of stuff that you should know for graduate algebra. Um, this is wonderful jokes there, Leo and Arad. But um, you should uh, yeah. This is why I suggest a Luffy to everybody, because it's a book that will be useful to you for a very long time, from early undergrad through grad school. Um, in my opinion, yeah, France, Germany, those would definitely be contenders as well. Um, the only reason I didn't say them, I was just thinking maybe like in terms of density of like number of like high level mathematicians, maybe some of these other countries just have more high level mathematicians currently there. But I actually have no idea what the actual numbers are. So there was a tradition for grad students at a certain level in your math department to not do problem sets for courses. What? And then one professor did not know this and was like, Psh, I'll just fail all of them. Yeah, fair. What? That's so weird. A tradition for grad students to not do problem sets? Yeah. I would, even if I was aware of the tradition and I came in, I would just be like, okay, too bad for you guys. Oh, you meant since the days of Gilgamesh until now. Well, if no math was, I mean, these other countries didn't even then Mesopotamia would be uh, uh yeah, mind you, yeah, I don't know actually, that's, I don't know, that's not true. Yeah, it'd be interesting, it'd definitely be interesting, but like, since I mean, in the days of Gilgamesh, I mean, then that becomes hard, because then we have to, if no math is allowed to leave countries, then how do you account for countries that dissolve, or new countries that are formed, like, or countries that get divided up? How would you account for that in this thought experiment? Um, Jokers are labeled in blue. Accurate. Yeah. Uh, G code is for programming embedded systems and specific controllers. I have no idea what that means. Had to do some assignments with it. A Luffy better than Dummit? Hot take. I agree with this, but only because, oh, we're not in live chat. We're in top chat. Hopefully I didn't miss anyone's messages, but I mostly agree with this, but this is just because I've just spent a lot more time with a Luffy. But Dummit and Foot, there are some things I like in Dummit and Foot. I mean, overall, I prefer Luffy because I think it slowly introduces the categorical perspective, which is indispensable for modern algebra. But Dummit and Foot has the advantage of, it introduces some representation theory, which a Luffy doesn't. And then I think it also deals with, like, I think in the Galois theory section, like, it tells you, there's like this theorem about if you have a polynomial and you look at the field of it and you're trying to compute its Galois group, and like if you look, um, it's like you look at it mod p, and if it has a certain factor of length, whatever mod p, then you know that the Galois group has an element of that order or something. Like I think you use, yeah, whatever. It's some theorem like that. I don't remember what it is exactly, but and I don't think a Luffy covers that. What's my most favorite theory? My most favorite theorem? I don't know. Actually, I mean, I do have a list on my website. I do have a list on my website of some of my favorite facts. So this is some of them. Yeah. Oh, there is a programming language called F Sharp? I had no idea. My PhD is in the local language program. It's a pity he doesn't cover representation theory and commutative algebra. Yeah. Oh, really? He mentions. I missed that part. He never did write chapter 1. Maybe he's still working on it. But he published some other book like a year ago, and it wasn't chapter 1. But yeah. I mean, the real answer is to read both Aloofy and Dummett and Foote. You know, a foundation of Aloofy with a side serving of Dummett and Foote. That's what I would say. Yeah. Yeah. Currently know very little CGA, but want to learn by making this tool. I mean, that's the best way to learn. Especially because there was a lot of courses required, so it was also a way to make the credits work out. Yeah, kind of an L system there. Sorry, I'm way behind in chat, gang. This is what it's gonna be like from now on. I mean, ideally, office hours just gets busier and busier. Right. Yeah, I mean all the exercises. Yeah. I mean, Aloofy is a very exercise-driven book, which was a little bit frustrating for me when I taught the Galois theory course, because I was planning lectures and I had to go back, and I was planning, writing up the proofs of theorems, sort of rewriting them in my own words. But, to save time, I was just looking at, the proofs in the book. But then, of course, many times he references exercises, and then those certain exercises, I didn't always want to assign those to my students. I'm like, okay, I just want to explain this to them and make them do different exercises. So then I had to go back and do a bunch of exercises, which, I mean, is fine, but also and probably ultimately good for me, but just slightly more annoying as an educator because it took a little more time out of my week. Y'all learning the stuff in university while you're struggling by self-studying this stuff in a very non-standard order. Well, you could try studying it in a more standard order, or just keep rocking. I just thought I need to. Well, I don't need to, but I want to. I watch back some of my videos, and I say and a lot, way too much. And it just dawned on me. I was trying to think, I should be using my live streams as practice sessions, but it's hard to remain consciously aware. So I'm gonna try and be consciously aware now. I was just reminded. I should put a note on the wall behind me. Don't say or I just did it a little bit. See? It's tough. It's a bad habit. But I want to sound smarter. You also want to learn more about rendering different points of view of the same environment manually. What CGA? You think exercises are overrated? No. Same with proofs. No, I don't know how much I agree. Although I do think, I did it again. I do think that when I get around to making some representation theory videos, hopefully sooner than later, that my videos will be focused on theorems and applications of theorems rather than the rigorous details of proof, which you can read in a book. So I think I'll mostly just explain the main important theorems and then do computations with them. That's the plan that's bubbling in the back of my mind. Never let him catch up, let it. Yeah. That's true. We do all say and a lot, but some people say it less. And I think some people edit it out of their videos. And I think it does make people sound smarter. And I do think it's a little bit annoying when I hear myself saying and too much. So that sounds like CELO being used on finite Galois groups, yeah. It's a nice landscape. Imagine talking about Langlands looking at that landscape. Wait, which landscape? Oh, you mean on my main page? Yeah. I was probably yapping about Langlands with someone while I was walking on this ridge. G-code is used to program printers. It's interface for assigning a label to different internal moving components. Okay. The short 1-minute video gives a quick introduction of all basic transformations. Put at the end of YouTube URL. Nice work around there, Locke. Nice work around there, Locke. It didn't tax it. By the way, you won't really find courses in CGA. You think you have to hunt around in Discord servers and YouTube videos to learn? I'm sure there's courses somewhere, notes or something. One of Vakil's requirements for being a grad student of his is you should be able to do every exercise in the Rising Sea. Before starting your PhD, better get working then. Better get to it, gang. Try to say skibbity instead of I will. If I can't catch up with chat, it means you made it a stream. Well, I've almost caught up with chat, so that's exactly what we did for my class too. Got to mess with 3D printer. You don't see the point of not humming or umming? Well, I think I said. I think I said why I see the point. Banning Locke for sneaking a link in? No. More like promoting Locke. Locke should get promoted. There should be other promotions I can give to people on here. Actually, there is. I can create memberships. For the channel. See, I just said I'm gonna get better at not saying it though. What's a deep theorem in representation theory that connects everything in representation theory and even other topics since CELO analogy failed? That's a good question. That's a very good question. Well, part of the problem is to try and answer that in general is there's many different aspects. There's many different aspects that come up, and representation theory means a bunch of different things. So, there's representations of finite groups. There's representations of compact groups. There's representations of Lie groups. There's representations of p-adic groups. There's representations of algebras. And these are all variations on a theme, and there's things that connect them. But I'm not so sure. I don't know what a deep theorem is that really ties all of these things together. Well, you could say Langlands. You could say the Langlands correspondence for GLN or something. Local Langlands correspondence for GLN. This ties together a bunch of different kinds of representation theory. So, there's possibly that, and then that also involves like topology and number theory and other things of this nature. So, let me go find Locke's message and go open this link. Where is it? youtube.com/ for some reason I remember pin message. Why can't I copy message though? Oh, there we go. There we go. Not found. Strange. Okay, whatever. Regarding my new video, what makes a field easier or harder? A lot of different things can make a field easier or harder. One thing is the amount of background knowledge that you need to break into the field. So, now to be clear, when I say easier, I mean one can still do, even in these easier fields, one can still do fields medal-worthy work, right? For example, though, I would say graph theory is, in many respects, I think, easier in the sense that there's a lot less conceptual overhead. There's a lot less background that you need in order to start understanding and even to start making contributions, start thinking about and making contributions. Oh, I have to have watch ?V before it. Watch ? Oh, thanks, Grad. There we go. Why is this here? Okay. I don't want these ads on my screen either. So yeah, again, I want to be clear. It doesn't mean that instantly your life is just automatically easier in graph theory, but there's just a lot less conceptual overhead, a lot less background you need before we can start doing why didn't we think of a link sooner? Well, not everyone can post a link, Shudo. Meanwhile, something like here's this paper in categorical local Langlands. So what do you need to understand the statement? I mean, this is a statement about infinity categories, but it's infinity categories that generalize ideas from algebraic geometry. So you need to understand quasi-coherent sheaves. You need to understand number theory and algebraic number theory. Like there's just so much stuff that goes behind this statement that it's just it takes a lot more background information. So that's an example of what I might say by harder. Sorry, New Wave Infantry. I missed your thing about automorphic forms. Could I write down a basic definition? Off the top of my head, no. Off the top of my head, no. I mean, an automorphic form, roughly speaking, is it's a function. It's a function on some group. You can think about it as a function in the L2 space, which has nice decay properties, and it satisfies a transformation law with respect to left multiplication under special kinds of subgroups. So that's the basic definition. That's a basic definition. And you should somehow think of them. There's an argument that you could think of them somehow as kinds of eigenfunctions on the L2 space of G mod this. It's maybe a conceptual way to think about them. But maybe, yeah, now I spend all my days trying to catch up with chat, but maybe tomorrow or something we'll crack open Getz and Han and read the definitions together. Needing to pass a qual to type in chat. That's the future of this channel. Yeah, to limit people. Once there's too many people, then you'll have to answer skill testing questions to type in chat. Automorphic forms are really subtle. There's a few variations. Generally, it's in, I see a rod beat me to it. But you can probably define them in terms of locally symmetric domains too. Entropy to differential. Entropy is one of the few places you've seen finite to compact analogy fail. Interesting. I don't know what differential entropy is. Maybe I could make a video with the word automorphic in math in at least Q0 different contexts. Oh, I think automorphic, mainly there's automorphic representations and automorphic forms. Unless you've made this up, number theorists take the longest to complete their PhDs on average. Yeah, I could believe it. Depends on the kind of number theory. Again, yeah, very Langlands-esque number theory. Now you're starting to get in, you're blending in multiple disciplines. So, of course, I'm going to say Langlands because I know it best, but any sort of field that ends up mixing a lot of different fields, and generally speaking, fields that are older, though not strictly speaking, are going to be harder just because there's more background that they draw upon. Rod is fed up with our mere mortals. Graph theorist dumb. Hey, Leo, don't you dare. I'm not saying that. Here, another threat. One of these days, my threats to remove your gear icon won't be empty. Starting a third book. Yeah. I can't finish a book before I start 5 other ones. You feel passing quals is a ticket for academic freedom? Kind of. Let's open. I don't know if New Wave Infantry is with us still, but let's crack open Getz and Han and let's see their definition. I mean, I think the first definition I ever saw was in Bump's book. Automorphic representations. Yeah, where do they define automorphic forms? So, automorphic forms. Actually, a good book to go on is perhaps Dietmar's book. Dietmar's book is nice because, where is it? Dietmar's book is nice because it talks about the passage in particular, because the book starts off, it explains, modular forms, and then later on it tells you how to go from the ordinary definition of modular forms to automorphic forms, and shows how you get that as a special case. So real to adelic. Yeah, this is what we want here, is this section. Why did this window get too big? The moment when you don't understand even the table of contents. Yeah. Welcome to math, baby. Growth and Daddy quote at the start is setting a tone. Yeah. To answer your question, Boris, I have no idea why. Because it is. Automorphic forms, no, other way around, Dason. Modular forms are a special case of automorphic forms. And maybe we should review how he defines modular forms as well. Because modular forms, you can view it as, modular forms are on the complex upper half plane, except actually it's the complex upper half plane, modulo this. Well, not exactly, because there's a fudge factor that comes out in front. So they satisfy some transformation property here. Well, but you can multiply, you can take a modular form and then multiply by the fudge factor to get something that really is defined on here. And then, or the inverse of the fudge factor. So, but gamma in this case is SL2Z, and then this is, you have SL2R acting on the upper half plane, and then you have SO2, is the stabilizer. So the upper half plane is SL2R quotient, SO2 on the right. So we have this general theme of G mod gamma on the left and mod K on the right. So with that in mind, I guess the one downside to Dietmar is he just talks about the GL2 or SL2 case to keep things simple. Although, to be honest, not a lot is lost in this. This is very representative of the general situation. What's the theorem that shows equivalence of analytic and algebraic definitions? Gaga? Yeah, that's Lady Gaga. Yeah, Lady Gaga and Adele. Yeah. Right. So, we have some setup theorems here. Right. So then this is an important theorem. We have GR mod GZ, and we get this equivalence with this adelic quotient here, right? So we have G over the adels, and then here we have G over Z hat, which is this compact thing, and then G over Q, which is this discrete thing, which also mimics, what's going on here, right? A G, a compact thing, and a discrete thing. Have I played the BuzzFeed which Springer GTM am I? I think I have a million years ago, but let me do it again real quick. Likely, here we go. You lost in a forest. What do you do? Navigate your way to safety using the sun as a compass? Probably. Ooh, sit and wait for a search party to find you. Actually, I've heard that this is the smarter thing to do. I'm not lost in a forest. I'm sitting at my computer. I've heard that this is smarter, but there is a part of my heart that feels like I would want to do this. But using the sun as a compass, I mean, I feel that this is very context dependent. If I knew the surrounding area well, I would maybe use a sun as a compass. So maybe, but maybe this for now. This is a hard one. I'll go back and change it after to see how that would affect things. At the grocery store, do I have a carefully established route and routine? No. Try to get in and out as quickly as possible. Yes-ish. What sort of colors do I prefer? Ooh. I don't know. I feel like I've gone through a lot of changes in my life regarding this. Maybe muted earthy tones. I don't know. Which of the following historical sites would you like them to visit the most? Probably the pyramids. In my morning newspaper, I always look at the chess column. Introduction to cyclotomic fields. Yes, that makes sense. I'm a carefully written exposition of the central area of number theory that can be used as a second course in algebraic number theory. Starting at the elementary level, you cover p-adic L functions, class numbers, Yeah, nice. That makes sense. Let's play around. Let's see. Does this change it? Arithmetic of elliptic curves. Okay, if I change it a little bit, yeah. Okay. Also tracks. What if I made pastel colors? Yeah, there's too many to change around here. Okay, still arithmetic. What if I did bright? Algebraic geometry. Nice. It all tracks. GA code debugging update. One of the horrors we have is that the dots / inner product in general is not symmetric. In your case, that was not the bug. This kind of reminds you, but the Cartan decomposition and all the matrix decomposition seen in linear algebra. I don't think, no, there's no way it covers all books. But it's just a fun little thing. You get Fulton Harris, though, even though you haven't read a lick of rep theory. Well, maybe that's a sign that you should be. Kind of embarrassing to be intro to cyclotomic fields. You're embarrassing. Okay, let's get back to automorphic form. I don't even know if New Wave Infantry's here. New Wave Infantry, wave if you're still here. Is that how many books there are? 1,024 is not much. That covers a good swath, though. But clearly, we've seen that there isn't a unique book for every combination. It's not injective. Right. So these theorems build up to give us this isomorphism of L2 spaces. The classic holomorphic modular forms as well as mass waveforms can be interpreted as elements of here. And yeah, Dietmar's definition of an automorphic form is to be an element of this L2 space. Yeah. Yesterday, he proved a new theorem that mogged this other theorem in a recent paper. Owned. I think that's where we'll leave it off for now. I think this is a good place to leave it. Yeah. So, thanks again for joining me. And maybe we'll do some automorphic forms tomorrow. Who knows? Who knows? Anywho, get some work done. QED.